Hi, thank you for joining me for our PreReq practice test tutorial. The purpose of this tutorial is to make sure you understand the whys behind each problem's answer so that it can make sense to you and you can put it in your long-term memory. Here we go with the first problem. We're going to get rid of 2 by subtracting 2 on both sides, which leaves us with a negative 3x. Divide both sides by negative 3, and there we have the answer. It's more than fine to leave it in fractional form. In fact, the fractional form is more accurate than the decimal approximation in this case. For our next problem, we're going to want to get the x's together. And so you could either subtract x from both sides, or you could subtract 6 from both sides. Either way, subtract 7 from both sides. And divide both sides by negative 5. The problems are going to get a little more difficult as we go on. With this one, we've got distributive property. So we're going to say negative 3x times x, negative 3 times negative 4. Same thing, distributive property. We're going to combine our like terms on each side of the equal sign. So we have 12 plus 5. And on this side, we have 3x plus 8. Then we're going to gather the x's on one side of the equation. So I'm going to subtract my 3x on this side. For some reason, I do gravitate towards having the x's on the left side, but you can certainly have them on the right. And then we're going to continue to work to make sure that x is alone. We're going to subtract 17 from both sides and divide by negative 6. So x will equal 9/6, or if we reduce that, that will be 3/2. Yes, 1.5 is also accepted here. I have to admit, it's a little bit strange to be teaching to an empty room and not checking to make sure everyone understands. So I'm hoping that if you don't, you pause, you slow it down, and you rethink. Here we've got an absolute value, and I reminded you guys in class that an absolute value means, in this case, that this value right here is 2 away from 0. So that means it could equal the value of x plus 5 divided by 4 could either be equal to 2, because that's 2 away from 0, or it also could be equal to negative 2, because negative 2 is also 2 away from 0. And so we're going to set up 2 different equations. Either x plus 5 is equal to positive 2, or x plus 5 over 4 is equal to negative 2. And when we solve these, we're going to go ahead and multiply 4 on both sides. I'm not going to solve both of them at the same time, although I can understand why someone would want to do that. It might get confusing. Subtract 5 from both sides, so x equals 3. That's one of the answers. Multiply 4 on both sides. And go ahead and subtract 5. So we have x is equal to negative 13. So we have 2 answers, and it makes sense because if you go ahead and plug 3 in, you're going to get 8 over 4, which is equal to 2. And if you plug negative 13 in, you'll get negative 13 plus 5, which is negative 8. Negative 8 divided by 4 is negative 2, but then absolute value of negative 2 is 2. Our next one, we'll want to cross multiply. I know in class some people were asking, well, should I distribute the 2 first and then multiply, or go ahead and multiply the 3 times 2 is 6. So you can do it either way. You'll get the same answer. I'm going to go ahead and multiply. When I cross multiply, I'll do the 2 times 3 is 6, and then I'll distribute the 7. So then we'll have the 6x plus 6 equals 7 plus 14x. Go ahead and subtract the 14x. And I'll get the negative 8x plus 6 equals 7. Subtract the 6 on both sides. And divide both sides by negative 8. So x equals negative 1 over 8. Okay, we're going to extract the square root, which just means we're going to take the square root of both sides, and that's why we're going to solve it. I cannot take the square root right away because I've got this 3 there. that 3 is not being squared. So I'm going to have to go ahead and divide by 3 first on both sides. So I can cancel the 3 on that side and have a 5 on this side. Now on the left side, I have a whole quantity that's being squared. And to undo that, I'm going to go ahead and take the square root. Once again, I get into the habit, whenever I take the square root of both sides, I put the plus or minus right in front, and that reminds me to bring it down the next line. We talked in class about why that plus or minus is necessary. Now we're going to go ahead and solve for x. We're going to get rid of the 7 first. And then we're going to go ahead. A lot of people think differently about how to get rid of the negative, whether you think of dividing by -1, multiplying by -1, or just changing each sign. We're going to get x equals, that's going to be a 7. The funny thing is the plus or minus still remains a plus or minus. And that is your final answer. It doesn't make sense to change the square root of 5 into an approximation using a decimal. So we're going to leave it that way because that's the exact answer. Okay, the next problem is we're solving by factoring. And so with this one, we want to think of two numbers that multiply together to equal -28 and that add up to equal -12. And so when I think about that, I think, well, I've got -14 and 2. Of course, I'm going to put the x and x, but the -14 and the +2 works because -14 times 2 is -28, and -14 plus 2 is -12. But of course, we're not going to stop there because it says to solve. And so we're going to use the multiplicative property of 0 to set each of one of them equal to 0. We're going to solve each one. We'll have x equals +14 and x equals -2. And if we took the time to go ahead and plug those into the original equation, we would find that when x equals 14, the left side equals 0, and when x equals -2, it also equals 0. Okay, solve by completing the square. With completing the square, we're going to keep our x squared term and our x term on the left side. We're going to make a little bit of room because we're going to drop something in after that. And then we'll have a 13 on the right side. So when we complete the square, it is another way to solve for x. In this case, even if we brought the 13 over and we had a -13, there's no two numbers that multiply to equal -13 and add to equal 6. So we couldn't have solved it by factoring, and we're not using the quadratic formula yet, though we may in another problem here. But it's asking us to solve it by completing the square, just like the PreReq test will ask us to show that we understand it. All right, so here are the steps. We're going to try to take the x squared plus 6x and add something that creates a trinomial, a perfect square trinomial. And so what we do is we take the number value of the x terms, that's 6, we divide it by 2, that's 3, and then we'll square it. 3 squared is 9. We're not allowed to just drop a 9 in on the left side. We've got to keep the equation balanced, so we'll add a 9 to the right side. When I factor this, I can see that it's going to be x plus 3 quantity squared. Another way to remember it is just that the x, the square root of x squared is x, the square root of 9 is 3, and we bring this sign down. And then 13 plus 9 is going to be 22. And then I kind of made a mess up here, but let me switch colors. So we'll do the square root to get rid of the square. And I'm going to remember, as soon as I do the square root of both sides of the equation, I'm going to put a plus or minus in front of there. So I bring that down, x plus 3 equals plus or minus root 22. Root 22, there's what, 2 times 11. I can't simplify that root. Certainly not a perfect square, so it has to remain that way. I'm going to subtract 3 from both sides. And that is my answer there. Okay, the next problem, it says solve by any method. I'm going to show you first solving by factoring. If you remember back in algebra, and hopefully you did a little bit in algebra 2 as well, you can factor this, but it's a little bit more difficult because now you've got the 5 to deal with as well as the -6. And so what you're looking for with the 5 is what times what is equal to 5? Well, we really only have 5 times 1, 1 times 5. So I'm going to go ahead and start messing around with some possibilities. I've got 5x, I've got 1x, which I'm just going to write as x. So that sets into motion, 5x times x is 5x squared, which is great because we've got the first term down. Now we need to think of two numbers that when multiplied together equal negative 6. I could use negative 6 and positive 1, but even if I put the negative 6 here or the positive 1 here, don't write that down because it's not right. To check to see if it's right, I take the outer plus the inner, and that should give me my middle term. Well, let's see, 5x plus a negative 6x, that's not going to give me 13x, so that's not going to work. Wonder if I undo it, see how far it goes. Okay. What if I did it the opposite way? I could put the 6 here. We can already see that's not going to work, and the 1 there, because then I would have 30x minus x, which is going to give me 29x, and that's not 13x. So that's not going to work either. So I know that I have to use 2 and 3. And so depending on, I can look and I can see that if I put my 2 here, that's going to give me a 10x. If I put my 3 here, that's going to give me a 3x. I want it to be since we've got the plus or minus for the negative 6, that's not going to work. I've got to put the 3 here and have that be a positive, and the 2 here and have that be a negative. So that gives us 15x for the outer and negative 2x for the inner. And when you add those two, you end up with 13x. Okay, if you didn't like that way of factoring, then you're just going to skip right ahead to quadratic formula. But before we go there, let me finish this problem by factoring. We're going to do the same thing where we set them equal to 0, either 5x minus 2 equals 0, x plus 3 equals 0. So my answers are, I'm going to add 2, so I'm going to get x is equal to 2/5, or x is equal to negative 3. If you like a challenge and you like factoring when there is a leading coefficient that is different than 1, you'll want to do it this way. If you want something that is a sure thing that will always work, you'll want to do quadratic formula. I will sing because why not? So we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah, you have to have that memorized. Hopefully your algebra teacher is saying that to you as well. So what we're going to do is we go back up to the problem and we label what a, b, and c are. A is going to be 5. That's my first term. B is going to be 13. That's my second term. And c is going to be negative 6. I'm checking that I'm still recording. Awesome. Okay, so what we're going to do is we're just going to plug and chug. Let's see, x equals negative b, that's going to be negative 13, plus or minus square root. 13 squared is going to be 169, minus 4 times 5 times negative 6, all over 2 times a, 2 times 5. You can plug this into your calculator. You can use a scientific calculator for this test. You could plug it into your calculator, the whole thing, or I kind of like to break it down, and that this is going to be the square root of 289. All over 10. And then what we're going to do is we're going to split it up. We have two different problems here. Well, first of all, we're not going to split it up because square root of 289 is 17, so we're going to simplify it real quickly. Then we're going to go ahead and split it up into two problems. One of our answers is x equals negative 13 plus 17 all over 10. And our other answer is x equals negative 13 minus 17 all over 10. Okay, so 17 minus 13 is 4. 4 over 10 can be reduced to 2 over 5. And then negative 3 minus 17, I'm sorry, it should be negative 13. Sorry that I wrote just a 3. So negative 13 minus 17 is going to give us what? Negative 30. And negative 30 divided by 10 is negative 3. Let's double check that that's what we got when we factored. There we go. So your choice. It says solve using any method. I'm not going to, on the PreReq test, force you to use factoring when we have a leading coefficient that's different than 1. So it's your choice if you want to use that. Once again, it's really weird that I'm not turning to you guys and asking you if you have any questions. So I'll keep going. All right, this one says solve using any method. We're not going to go straight to quadratic formula because, I'm sorry, we are going to go straight to quadratic formula. We are not going to go straight to factoring. If I looked at this and I rewrote it as x squared plus 10x plus 29 equals 0, obviously it cannot be factored. So we could go ahead and complete the square, or we could use quadratic formula. Why don't we complete the square just because we need more practice with that? Once again, it's an option. If it says any way you want to, you can go straight to quadratic formula. So I'm going to go ahead and leave it blank. I'm going to kick that 29 to the other side. I'm going to subtract 29 from both sides. So I'm leaving it blank so that I can create a perfect square trinomial on this side so that it factors really pretty. So I take 10, half of 10 is 5, 5 squared is 25. I'm not allowed to just drop in a 25 on one side without dropping it in the other side. So that's what I'm going to do. So then it's a perfect square trinomial. So that means that I'm going to factor it and rewrite it. Square root of x squared is x. That's where that comes from. Square root of 25 is 5. And the sign is a positive. And negative 29 plus 25 is negative 4. And a lot of people are like, oh, it's negative. Okay, let's stop there because we can't take the square root of a negative number when we do. But we can, and we will. So here we go. We're going to get rid of that square by taking the square root of both sides. We're going to remind ourselves every time we take the square root of both sides of an equation, we're going to put plus or minus. And so what's left? The square root and the square cancel each other out. We have plus or minus. All right, let's hold everything. What's the square root of negative 4? Well, let's go over here real quickly. Square root of negative 4 can be rewritten as the square root of 4 times the square root of negative 1. These are the same exact things. And so we know what the square root of 4 is. It's 2. And hopefully in Algebra 2 Trig, you remembered or you learned that the square root of negative 1 is an I. So you can go through the method this way to get to the 2i, or you just can remember when you have a negative there, you're going to tack on an I to whatever the square root of the positive number is. So we're going to have a plus or minus 2i, and then we're going to subtract 5 from both sides to end up with this. Once again, you could have used the quadratic formula to solve this. All right. Let's go to number 11. All right, I'm having a technical difficulty here. Hold on. Okay. Number 11, find the equation of the line that goes to the points 1, 4 and negative 2, 7. And so the first thing we're going to do is we are going to find the slope. Which is negative 1. Okay, so our slope is negative 1. And then if they want it it doesn't say slope-intercept form. Okay, well, I'm going to use a slope-intercept just because most everybody remembers y equals mx plus b. And I'm going to immediately, now that I know that the slope is negative 1, I'm going to plug negative 1 in for m. And I'm almost done. I need to know what b is. And so I have a choice. I can choose 1, 4 and plug that into what I have so far, or negative 2, 7. I'm going to pick the easier one, 1, 4, which means that when I see y, I'm going to plug in the y value. So I'm going to plug in 4. When I see x, I'm going to plug in the x value. And then b will be the remaining variable that I have there that I can solve for. So I'll have what? 4 equals negative 1 plus b. I'll add 4 to both sides. So b is equal to 5, and I'm going to come back and place that right there. So my formula, y equals negative 1x plus 5 should work. You can always double check. If you plug in the 0.14, if you plug in 1 for x, you'll have -1 plus 5, which is 4. And if you plug in -2, you'll have 2 plus 5, which is 7. So that's a good deal. Okay. The next one, number 12. Find the equation of the line that goes through 9, 1 and is perpendicular to the line -3x plus y equals 11. First thing we're going to want to do is understand how lines, perpendicular lines, are related. Basically, if you've got two lines that are parallel, they're never going to touch because they have the exact same slope. Their rise over run is exactly the same to each other, the same as each other. So parallel lines have equal slopes, but perpendicular lines, I don't know if you remember this rule, we did teach it in algebra, perpendicular lines have negative reciprocals of each other. So let me show you how this is going to work. First of all, I have to figure out what is the slope of this line right here. So I'm going to take this, and I'm going to go ahead and solve for y. I'm going to isolate y. I'm going to add 3x to both sides. And I can see right now that my slope is going to be 3. Okay, so the slope of the given line is 3. So if I want to find a line that's perpendicular to that, I take the 3. First thing I do, this is how I taught it in algebra, is I make it into a fraction. So I go ahead and say 3 is 3 over 1. And then it's going to be the negative reciprocal. So that means if 3 is positive, which it is, the next formation it goes through is it becomes negative. And reciprocal means to flip. So the next thing it's going to go through is to flip. So my new slope of my new line is going to be equal to -1/3. So once again, when you see this problem, you're going to want to isolate y so you can get the slope-intercept form, figure out that the slope is 3, and then do the little transformation to find what a line that's perpendicular to that, what the slope of that line would be. You take it, you change it into a fraction, you take the negative of it, and you flip it, and that's your new slope. So now we've got the new slope of the new line. We're going to plug it in here. And we've got the same problem as we just finished up, where we're going to, we don't have 2 points to pick from, so we've got to pick the 9, 1. The 9 is going to be plugged in for x. The 1 is going to be plugged in for y. So you've got your 1 equals -1/3. Plug in the 9, and we're going to go ahead and solve for b. So we'll have 9 times -1/3 is -3. Go ahead and add 3 to both sides, and we're going to put that with our equation, which I'm just going to drop down here. It's going to be y equals -1/3 x plus 4. You take the time to drop 9, 1 in. If you drop 9 in, you're going to get -3 plus 4, which is 1, gives us y equals 1. Okay, so now we're moving on to some word problems. Let's look at 13. Okay, there were 770 defects in Ford automobiles in 2001 and 285 in 2011. Predict how many defects there were or there will be in 2013. Assume that the number of defects continues to follow the same linear trend. That was important. If we didn't know that it was following a linear trend, I mean, it could be exponential, it could be, it could be not have any relation. So we know that it's linear. And so basically what it's saying is, can you go ahead and use this information to find the slope, to find the trend, to then go ahead and predict. So I see the 770 in the 2001, and I say, well, that looks like a point to me. In 2001, there were 770 deficits or defects. In 2011, there were 285 defects. All right, so I put the time first because almost always we're looking at time as your X variable and the results, whether it's money, defects, hours worked, or sorry, that's hours worked is going to be time. That's going to go on the second place. So time usually is a independent variable. Okay, so here we go. I've got 2 points. I'm going to go ahead and find the slope. And so to find the slope or the rate of change, I'm going to go ahead and put 770 minus 285 all over 2001 minus 2011, which is going to give me 485 over negative 10, giving me a negative 48.5. And this makes sense that our slope would be negative because the defects are going down as time is passing. And so now that we know the slope, we can just say, okay, then let's take this 285 that was, let's take the 285 that was in 2011, and they want to know, predict how many defects there will be in 2013. Well, that's two more years, so we know that it's going to fall by 2 times. Well, I shouldn't have put the minus there, so let's just go ahead and 2 more years will pass, and each of those years it's going to fall by 48.5. And so when we do the math there, we're going to get 188. So there'll be much less defects in 2013 than in 2011. Okay. Let's move on to the next problem. A construction company buys a truck for $78,000. After 5 years, a truck has depreciated to $55,000, which I have to stop and say, this is a sad fact, okay? We buy these cars or trucks, and they decrease in value. All right, I guess that's why we have to turn around and buy new ones. All right, express the value of the truck as a linear function of the number of years since it was new. Okay, so what I see is if a construction company buys a truck for $78,000, that's the initial value. That's where, before time began, before you drove it off the lot, or this company drove it off the lot and the time started ticking, at 0 time, the cost of the truck was $78,000. So that's going to be one of my points. And then you can see our other point is going to be at 5 years, after 5 years passed, the truck was only worth $55,000. So as soon as I can take what's given to me in words into math, then I know what to do with it. Because now I have 2 points. It asks us to express the value of the truck as a linear function. So we're going to go ahead and use our 2 points and do the slope. Which gives me a negative 4,600. Of course, the truck is depreciating then $4,600 every year. So we're almost there. That's my slope. So I'm going to go ahead and, oh, you know what? I'm almost actually done because that's my slope, and I don't have to figure out my y-intercept because they gave it to me. My y-intercept always represents the initial value or in the beginning. So we already have the 78,000. We can put it together, and the slope is negative 4,600, and the y-intercept is 78,000. Okay. So then it says interpret the slope and y-intercept in part A. I kind of already talked through that, but I can, you're going to need to write in some way to show that you know that the negative 4,600 represents depreciation. How about amount of depreciation each year? Amount, or we can say yearly depreciation. Amount of depreciation each year. Okay, I'm looking for you to write something that shows me that you understand what a slope really does represent in this problem or any problem. So 78,000, I talked about that as well, and 78,000 is the initial value. In the beginning, it had the value of 78,000. Okay. According to your model, how many years will it take for the truck to have no value? Okay, that's going to be a sad, sad day. How are we going to do that? Well, we're going to take our formula for the truck's depreciation, and we're going to remind ourselves what each variable stands for. When we look back at the coordinate point, the 5 stood for number of years. So X stands for the number of years, and Y stands for the value of the truck. So they're asking, how many years will it take for the truck to have no value? So no value is zero, $0. So that means that I need to look at the variable that represents the value, which is the Y variable, and I need to just plug in 0. And so basically when we do this and we solve for X, we're going to find the number of years when it will finally be worth 0. So here we go. We're going to go ahead and subtract the 78,000. We'll divide by the negative 4,600, and we'll get 16.95. So you can leave this as this answer, or you could write almost 17 years. It wouldn't be correct to say in 16 years, because at 16 years it did have some value. I don't know, maybe $5 or $10. I'm not sure. But almost 17 years, it literally had no value. I don't think that's technically ever true. I mean, a truck or a car can get so old, but it still has some type of value, maybe for scrap metal or parts. So, okay, not totally true to life. Okay, here we go. The price of admission to a high school play was $2 for students and $55, I'm sorry, $2 for students and $5 for non-students. If it's $55, there are not going to be non-students there. If 375 tickets were sold for a total of 1,215, then how many of each kind was purchased? When you see a word problem like this that has so many different numbers, you know that you're probably going to have to set up a system of equations. You're going to have to set up not just one, but 2 equations. And the first thing you want to do is decide what stands for what. When I see students, I'm not going to use S for students because S looks like a 5 to me. So I'm going to say for this problem that X represents the students and that Y represents the non-students. So I'm just going to stick with X and Y. And I'm going to try to put together the easiest formula first. I noticed that it tells me a couple different things. It tells me how many students, non-students I had altogether. So that's about the amount or the total people. So I'm going to start there. If there's 375 tickets sold, and I know that the tickets went to both students and non-students alike, then I've got my first equation. So my first equation is about number of people, and then I look at the other numbers that it gave us, and the other numbers have to do with a value, a dollar value. So I see a $2 for students. I'm going to represent that as 2x, which makes sense. If there's 10 students, 2 times 10 is 20, then $20 tickets were bought. $5 for non-students, then I'm going to represent that as 5y. So this would make sense depending on how many students and how many non-students. Altogether, there was a total of $1,215 worth of tickets sold. I'm not sure if that makes sense, but all right. So here we go. I'm always looking when I look at these problems for what are the 2 different equations. Were the 2 different equation types I'm looking for. So now that I have the 2 equations, now I have to decide how I'm going to solve it. Am I going to use substitution? Am I going to use elimination? We can go either way. I think I'm going to go ahead and use elimination to show you guys that, because I think that's probably easiest here. If I go ahead and I used to teach it as make-a-wish. I see this x and I see this 2x. If this were a negative 2x, I could add these 2 equations together. So that's what I'm going to do. I'm going to rewrite this. I'm going to multiply every term in this equation by negative 2. That is legit. I can do that. If I multiply every equation by every term by negative 2, that's not changing the value of the equation. It's making it look a little different. It's got a different disguise, but it's still the same equation. So let's see, I'm going to have negative 2x minus 2y equals 375 times negative 2 is going to be the negative 750. Okay, So I'm going to go ahead and bring this right underneath it. And I'm going to add. So the reason why I multiplied everybody by -2 is so that the -2x and the 2x could cancel when I add. And then we have -2y plus 5y is 3y. And we've got the -750 plus the 1215 is the 465. We're going to divide both sides by 3, and we'll get y equals 155. What does y stand for anyways? The non-students. So now I'm going to go back to my easier equation, the x plus y equals 375. And I'm going to say, well, if y is 155, then I'm going to go ahead and do the math, subtract the 155, and I get that the students were 220. So then we would just go ahead and fill in the students are 220, and the non-students are 155. Don't worry if you're a little rusty on these word problems. You will have more of them on practice test 2 and practice test 3 to practice with. Okay. Okay, I've got 215s. Okay, here's 16. A merchant wishes to mix peanuts costing $2.50 per pound with cashews costing $7.30 per pound to obtain 55 pounds of a mixture costing $5.50 per pound. How many of each variety should be mixed? So this is a mixture problem. I think you've been exposed to these in Algebra 2. These are definitely something that needs to be, we need to use systems of equations to set this up. So we're going to do the same thing we just did. We're going to look for the easiest equation first. Let's go ahead and make P equal to peanuts and C equals to cashews, because P and C are good letters to work with. And I noticed that I see 55 there. And when I see the 55, it has to do with how many pounds. So imagine this mixture that we're making. This mysterious mixture. We don't really know yet how many pounds of peanuts and how many pounds of cashews we need exactly, but we do know that the peanuts plus cashews together in this mysterious mixture are going to equal 55 pounds. So we got rid of the 55, and we've got a lot more numbers left. We've got the dollar amounts. So we're going to combine. We've got peanuts costing $2.50. Okay, that makes sense. So I'd put the 250p, because depending on how many pounds of peanuts I put in, each pound is going to cost $2.50. And I'm going to use this 730 because cashews are way better. No, maybe you like peanuts better, but cashews are pretty yummy, and they are more expensive at Trader Joe's. So 730 times C, that's going to represent that. And then, you would say, oh, 550. Just put in the 550 on this side. No, don't do it. Don't do it. That's wrong. Okay, let's stop and look at what we got. We're making this mysterious mixture, and so it's 55 pounds of this mysterious mixture. And it says if we're putting these all together, then we better have a total cost altogether. So let's go ahead and think about that. If the new mixture is $5.50 per pound, then on this side, what we're really going to have is the cost, $5.50 per pound. And how many pounds is our mixture? 55. So we're going to have to do a little multiplication first. So let's rewrite this. We'll have 250p plus 730c equals 5.5 times 55. And I believe that that is 302.5. Okay. We're going to use this equation and this equation. And I'm going to once again use elimination. If you want to see substitution, ask me about it in class, and we can do that in class. So elimination is going to say, wow, I've got a 250p here. If I had a negative 250p there, then they would cancel each other out. So I'm going to go ahead and multiply everybody by negative 2.5. Oh. Okay. And it's going to be times negative 2.5 times negative 2.5. So here we go. P times negative 2.5 is negative 2.5 P. And then we've got negative 2.5 C. And then 55 times negative 2.5 is, okay, I've lost it. Okay, I'm going to pause. I got to grab a calculator. Okay, so it is negative 137.5, and then I'm going to go ahead and add these two together. These cancel out, and we end up with 4.8C equals 165, and when we solve for C, we get 34.375. And so we're just going to approximate that. We're going to say approximately we're going to need 34 pounds of cashews. And when we go ahead and plug this into the easier equation, we're going to write P plus, I'm just going to use 34 pounds just to approximate, equals 55. And so P is equal to 21. So we'll need 21 pounds of peanuts and 34 pounds of cashew. Okay. I don't recommend doing this practice straight up all the way through. Even though I'm going 40 plus minutes strong, go get a snack, walk around. That's important. Okay, 17, solve the following rational equation. So rational number can be expressed as a fraction, so that's why this is called a rational equation. I look at denominators and I don't like them in an equation. I want to get rid of them. So that's what we're going to do first. Let's stop for just a second and talk about x over 3. If I multiplied x over 3 times 3, would you agree that the 3's would cancel out and I would just get an x? Okay? I'm not in an equation right now. I'm just talking about it. And so it would be awesome if we just went ahead and said, I'm going to multiply everybody by 3. That by 3, that by, but that's not going to help us on a 1/4 if we multiply by 3. That's just going to give us a 3/4. So we want to pick a number that when we multiply each of these terms by it, the denominators go away. So think about 3 and 4. What number do we need? That's right, 12. Okay, so we're going to multiply every single fraction by 12. As long as we do the same thing to each term, we're still keeping the integrity of the equation intact. So here we go. 12x over 3, I'm going to say that is 4x. 12 over 4, that is 3. 12x over 4, that is 3x. And 12 over 3 is, oops, it's a minus, is a minus 4. I am not finding common denominators so that I can add them. I'm just getting rid of the denominators. So when you do that, this equation is equal to the value of the original equation. It's just a lot nicer to work with, don't you agree? So I want you doing this whenever you see fractions in an equation. And then we're going to go ahead and solve it. We'll subtract 3x from both sides. And we'll subtract 3 from both sides. And we got it. We are almost done. Let's go to 18. Name 3 ways to solve quadratic equations. Okay, we've got factoring. We've got completing the square. And we've got quadratic formula. Sometimes we can actually use a graph of a quadratic to solve it, but that's not true for every single point on the quadratic. Kind of hard to estimate looking at a graph. Okay, 19. Here's the deal. We're going to pretend that that greater than sign is really an equal to sign. And we're going to go ahead and just start distributing. I'm going to write it as a greater than, but I'm just going to act like I'm solving an equation. Okay, Now I'm going to gather like terms. So I've got the negative 16 minus 13r. Okay, now I'm going to get my r's on the same side, so I'm going to go ahead and add my 44r. Let's see, actually I did two things. All right, hold on. So that's plus 31r. And I'm going to go ahead and add the 16. And divide by the 31. And I get r is greater than 3. Okay, so the nice thing was, excuse me, I wasn't multiplying both sides by negatives. I wasn't dividing both sides by negative, because if we had that, we would have to flip the greater than sign. Okay, the last one, absolute value. Here we go. So the first thing I have to do is get the absolute value all alone. So I'm going to go ahead and subtract the 2 from both sides. So there we go. And looking at this, what we're going to do is we're going to remember what it means to be less than, for an absolute value to be less than 4. All right, so let's go to the number line. If it were an equal sign, if it said this 5 minus 4x has to be exactly equal to 4 away from 0, we would say, oh, that's easy. I'm going to set it up equal to 4 and equal to negative 4, have two equations and solve. But it says less than 4. So if we look at our number line here, it's saying it can't be equal to 4. It has to be less than 4 away from 0. Same thing, there's no way it can be equal to negative 4, because it has to be less than 4 away from 0. So what you see shaded is actually where this answer has to fall. So here we go. We're going to, or rather where the value of the absolute value of 5 minus 4x will fall. The answer x is not going to fall in here, but the value does. So what we're going to do is we're going to say, okay, so either 5 minus 4x is less than 4, right? That if it's less than 4, that takes into account this side. So it's going to be less than 4. And 5 minus 4x has to be greater than negative 4. It has to be both things. And there are two equations. So just like with the absolute value in an equation, we're going to have two things to solve for in an absolute value inequality. So we're going to go ahead and just solve. We'll go ahead and subtract 5 from both sides. We're going to divide both sides by negative 4. Oh, okay, let's stop. We're dividing both sides by negative 4. When you divide an inequality by a negative number, your inequality switches. So we're going to switch it right away. So we get x is greater than 1/4. And then we're going to go ahead and subtract the 5 from both sides. Divide by negative 4. Once again, we're dividing by a negative number, so our inequality sign flips. And there you have it. If you plug these numbers in, you will see that they work. And we finished. We did it. If you stuck with me the whole time, congratulations. If you just joined in for the very last few problems that were difficult, glad you joined in. I'll see you guys in class. Thanks for joining me. Bye.